And in the interest of transparency, Peter, I'm from the Canadian Food Inspection Agency. My group actually was responsible for the risk assessment on the SmartStax product. So I was interested that we had the earlier discussion about conventional breeding, and I appreciated the nod to the PNT approach in Canada. And I'm going to take a little bit of issue with you, Peter, in saying that this was economically driven, because in fact it was a recommendation that came from the scientific community. And it was interesting, what I found really interesting was the questions about conventional breeding, because I'm sure as you're aware, Ricarda, conventional breeding includes chemical mutagenesis, irradiation. A lot of the breeding that happens, for example, in Simit in Mexico with their wheat improvement, they're using jointed goat grass, which is a related weed. Wheat and jointed goat grass share a common genome. So you're looking at introgressing an entire genetic package, not a single gene. And of course, I'm sure you're familiar that there was a recent study, I think 2005, the National Academy of Science in the US identified where the highest incidence of unexpected effects was actually as a consequence of mutagenesis and mutagenesis breeding. Not so much. So again, I think it's worthwhile to put the whole concept of SmartStax into that context and how we deal with conventional breeding. And I think Canada, maybe we have a little bit better perspective, at least with the novel plant approach. And I'm not going to touch on the other science because I'm going to leave Health Canada talking about allergenicity in their own studies, but I am going to talk about SmartStax and the refuge. And one thing you'll find when you start talking about insect resistance management is it's very long on theory and very short on actual data. And I think when we made the decisions, it was a long and convoluted process. We did deal extensively with the scientific community. In fact, we dealt with the Canadian Corn Pest Coalition, which are a multi-stakeholder body. What we did was consistent with the models. It's consistent with what the models showed for multi-traits. And that was why, in the end, we went, and the actual critical piece of evidence there was the density-dependent mortality models for rootworm, which are published, that's also peer-reviewed published literature, I think 2007, 2008, the Storer model. So the reason for the conditional authorization was, I think as you pointed out, Peter, it was an opportunity for us to then look at that and say, well, to make sure that we're still in the right realm of science, and that is going to be something which is going to be more transparent. And again, in the whole interest of how we deal with peer-reviewed science, on a product-to-product basis, it's always something which is highly difficult for us. I mean, these are proprietary products, and I think Canadian taxpayers expect people who develop these products to develop their own safety information. So what we do is ensure that we have the right science to make regulatory decisions, which is why we do have an extensive program of supporting science and regulation and through the scientific community, which is available, and we certainly be quite available to talk to that link to anybody who's interested. As we think about this, about mutation breeding and how we look at those things, do you think then that we do really, it's consistent when you can have herbicide tolerant crops that are group 2 mutants? They're things that are also resistant to broad spectrum herbicides, which can have the same environmental issues, which escape regulation in the EU and other places in the world, whereas we have this whole layer of regulatory oversight on another range of products?
I thought you would pose that question, Bill. We know each other well because we serve on the same RTEC group, at the technical expert group from the biosafety protocol, just in case you were wondering. And we have these discussions also in closed doors, not just here in the open. My point has also already been to you in the group is that I think it is that aspect of the Canadian regulation that you also look at mutagenesis and the novel traits in that way. I think that is very good because we have to look at impacts. I mean, if there is impacts from traditional breeding, but I mean, there is still a different way to go about, to say, traditional breeding and mutagenic breeding, because I was exactly saying it is these. In genetic modification, if you insert the gene, it is a big part which causes the mutations is the tissue culture in that. And the tissue culture is exactly what is being used to do mutagenic breeding. It is one of the mutagenesis tools, right? So that means, of course, they should be looking at it, but my expertise is that of a geneticist. And I do not doubt that there is areas where one should look at in traditional or in mutational breeding. But the fact that in other areas we have problems does not relieve us from having to look at the problems we create with genetic engineering. So therefore, please feel free to initiate sort of another our take on that or in a different gremium, because I can see that there is obviously a need to assess more on that. But maybe you wanted to say something to that as well.
The one comment I would make is on the National Academy of Science study you referred to. If you look at that graph that had the potential for unexpected effects, and it did have that said that mutagenesis was the largest one. If you look, there's not studies that they used to actually create those bars. It was just this general stuff. And as I pointed out when I testified before that committee, I can show you studies, the Bergelson and Purrington, who looked at Arabidopsis thaliana. They created an herbicide tolerance through using EMS, which is a chemical mutagen, which causes insertional mutations, which are, of course, among the most disruptive. So they isolated the gene. They created it by chemical mutagenesis. They isolated the gene that was then responsible, and they put it into the same ecotype of Arabidopsis thaliana via genetic engineering. And they used the simplest case, which was a single genetic assert, a single insertion site, no rearrangements. That's the most stable case for genetic engineering compared to insertional mutagenesis, which is one of the most mutagenic forms, I would say, for conventional breeding. And then they crossed them and looked at outcrossing rates, and it turns out that there was a 20-fold higher rate of outcrossing for the engineered trait compared to when it was done via mutation breeding. So that's a side-by-side comparison, and I've tried to find if there are other studies you know of where they've done side-by-side with the same genetic background. I would love to talk to you about those.
Yeah.
So.
And just briefly, like one more point, because you mentioned peer-reviewed. And for me, it's also important that we look at the, what you call it, the notification or what, the whole stack, which is the application. Do you call it application here?
The data set?
Yeah? What?
The data set?
The data set. Because I feel like that the whole assessment and the data set, that actually should be peer-reviewed. It's not just about using peer-reviewed information when doing the assessment, because one part of peer review which is so crucial is transparency, but when you read a paper that you know what's been done, but also that you can repeat it. And that is the one thing which is just impossible. If we as the scientific community want to repeat any of the studies, we can't, because the information is not available, the methodology is not available in the way that we could do it with some of the studies, but also we don't get the material, and that is for testing, and that is a very crucial point as well. So I mean, like we've been discussing that a bit in the Arctic, sort of like the scientific rigor of the material that is being handed to the assessors, and that's where we also have like lots of room left for improvement.
Great, thank you. We have a question from Mr. Mulcair.
Hi, Thomas Mulcair, Member of Parliament for Outremont, Quebec. First of all, I wanted to congratulate CBAN for an extraordinary evening. It's been great for us, and to thank the three presenters, full of information, lots that we can take back. I was the Minister of the Environment in Quebec for a number of years, and I can tell you that Dow Chemical is not very pleased with me or my predecessor because we banned 2,4-D for cosmetic uses in Quebec. And what they've done is they've taken an action under the North American Free Trade Agreement, similar to the action taken by the Ethel Corporation when its gasoline additive was banned. And I think that you are sitting on the nexus of probably the most important trade issue for the next generation, for the next 25 years. It's who can limit what and say that it is a legitimate barrier to trade as opposed to something in their self-interest. And I can also say, as someone who's had to deal with scientific issues without being a scientist, as being a minister, I have many years, I'm an attorney, I've got many years experience in regulation, but regulatory capture is one of the greatest dangers, and it's the notion that people who work too closely with a given industry tend to wind up giving the arguments of that industry, and I think we had an example of that from the representative of the Canadian Food Inspection Agency before, and I find that very disquieting. Our obligation is to regulate and enforce in the public interest and not in the interest of these manufacturers. And